What's up, guys? It's Mr. Bringle, and today I'm going to be going over some variables and units for our math unit in energy. So, talking about kinetic and potential energy, and we're going to be going over the variables and units that we'll be using for these math problems. And then in a separate video, I will go over some examples. So, let's jump right into it here, and let's start by talking about kinetic energy. That's what this KE stands for, is kinetic energy. Okay, so you can see that right here. And kinetic energy is measured by multiplying mass, which is the M here, right? Mass, which we've learned about before, times the velocity squared. Okay, so an object's velocity, and then we have to square that value, and you're just squaring the velocity, not the mass. So if the mass is 10 kilograms and the velocity is 5 meters per second, we would square the 5 meters per second. Then we would multiply it by the 10 kilograms. And then you have to cut that in half. Okay, whatever you get after you multiply those things together. Okay. Now, this second equation here is actually the same thing. Okay, so these two equations here and here are the same thing. However, it's just been rearranged to solve for the velocity of the object. Okay, so we go ahead and rearrange this for you, but you might be given a question that says solve for the kinetic energy, and it gives you the mass and the velocity. Or it might say solve for the velocity. It gives you the kinetic energy and it gives you the mass. Okay. So after looking at these, you can see that kinetic energy is always involving some sort of movement because the object must have velocity, right? It has to have some sort of velocity, which means that it's moving. So kinetic energy, the word kinetic means moving. So these two equations will be used when an object is moving. Okay. Now, moving on here, we also have potential energy. Okay, and there's a lot of different types of potential energy, but we'll go ahead and underline this potential energy here. And potential energy is energy that's stored up. So this potential energy here is really referring to gravitational potential energy, because you will notice that besides multiplying the mass of the object, which again is right here, you also have to multiply it by the acceleration due to gravity. Okay, we've talked about this before. This is 10 meters per second squared, always. Okay, and just remember that that is just the number 10. It's the units that are squared. The seconds are squared, so you don't have to square that number. You just plug in 10. So whatever the mass is, let's say 5 kilograms multiplied by 10 meters per second squared, you would just do 5 kilograms times 10, and then you would also need to multiply that by the height of the object. Okay, so gravitational potential energy is stored when an object is above some reference point. So for instance, if I have my coffee mug here and I set it on the desk, and it has the ability to fall off of the desk, right? And so it has some height above the floor. And that's what that's talking about. If the floor is the reference point, what we're counting as 0 meters, then it is above the floor. So you would be given the height of the object. Now, obviously, this equation right here, there are 3 versions of it. It's all the same thing. It's just rearranged for different things. So in the second one, we're solving for the mass, and the second one, we solve for the height. Okay. So really just 2 equations here, even though there are 5 equations on your screen here. There's really just 2 equations, and we just rearrange them and solve for different things. So we kind of split it down right there. We have kinetic energy, which involves mass and velocity, and then we have potential energy, which involves mass, the acceleration due to gravity, and the height of the object. Now, let's kind of go back through and talk about some of the units here for these things. So you will notice that both potential and kinetic energy are measured with a J, okay? And that J stands for joules, okay? Joules, joules. And that's how we measure energy. Okay, joules is how we measure energy. And then just a review of some of the other things that we've learned about. You obviously we have talked about mass, which is measured in kilograms. We have talked about velocity, which is measured in meters per second. Your height would be measured in meters. That is a distance value, just vertical instead of horizontal. And then we know that the acceleration due to gravity is an acceleration value and is therefore measured in meters per second squared. Okay, so just remember that joules is the measurement for energy, and its symbol is a capital J. In my next video, I will go through the example problems on this page. Make sure that you ask any questions about the variables and units that you might have.